Hello friends, I'm going to teach you now RC couple amplifier with load variation. Amplifier means the input signal is going to be amplified. That means any sine wave whose amplitude is going to be amplified. You can say they defined like this way, that DC energy is going to be converted into AC energy according to the AC input signal, that is known as amplifier. Frequency does not change, remember. Whatever input frequency you give, the same output frequency will be there, but only the amplitude is going to be increased or decreased. That is called amplifier. And because it is a common emitter configuration is there, so 180 degree phase shift voltage is also going to be there. So if there is an input is going to be the positive signal, output is going to be negative signal, but it is going to be enlarged version is going to be there. That is called amplifier. Now it is RC couple amplifier. It means that resistance and capacitor is utilized as a coupling between the different stage. So input stage and output stage, it is going to be coupled with RNC. That's why it is called RC couple amplifier. This is normally utilized for low frequency amplifier. That is audio frequency amplifier from 20 Hz to 20 kHz. Input we are connecting with the EFO. We are giving through the input a sine wave signal, and that sine wave signal we are giving the inner frequency range from 20 Hz to 20 kHz or something like 100 kHz, something like that. And we are varying this frequency, and over a different frequency amplitude is going to be changed, and that we normally measure. But here what we are going to do, that is called frequency response curve. Here we are not going to change the frequency. We are keeping constant frequency. Let us say we are going to give 1 kHz input frequency, and the input signal should be kept of 20 millivolt or something, and we'll be measuring the output voltage. Now between the VCC and collector of the transistor, this is NPN transistor is there. So between the collector and VCC there is a load resistance we are using, across which you are taking the output. If you are changing this load resistance, the output is also going to be changed, and that you are going to see here. So that is called the load variation. So we are changing the load resistance from 100 ohms to 2000 ohms or 5000 ohms or 10,000 ohms, like that way. Up to 10,000 ohms will be varying this. And what is the output voltage is going to be there, that we are going to see. When this load resistance is equal to the output impedance of the amplifier is going to be there, then the signal is going to be the maximum. Power transfer is going to be the maximum. That you can see that in a power transfer theorem. When the source internal resistance is equal to the load resistance, then the maximum power is going to transfer is a 50%. And that way you can find out the peak signal in a load variation. Okay, so now we are going to do the practical.